Wait, I know. This setup looks a little strange, right? I have actually got two displays running here. On the left, I have this AI vision camera which makes getting vision data super easy. And on the right, you can see my ESP32 device with a screen. For this project, I built a system that recognizes license plates using that AI camera. Since license plate numbers and letters are standardized, the recognition rate is actually way better than trying to read random text. Now, as you probably know, doing heavy AI work directly on ESP32-S3 can be really difficult. So I'm letting the AI camera handle the heavy lifting. The ESP32 is just there to control the camera, filter the data, and handle the display. They talk to each other over a simple UART connection. This isn't just a camera, it's a complete vision computer. Meet the HuskyLens2. At its heartbeat, a Kendryte K230 dual-core processor running at 1.6 GHz, delivering a massive 6 TOPS of AI computing power. That is paired with 1 GB of RAM and 8 GB of internal storage, meaning it processes images faster and stores more models than ever before. It sees the world through a 2 megapixel camera running at 60 fps, displayed on a 2.4-inch IPS touchscreen. Beyond the standard tracking, the HuskyLens2 supports advanced instance segmentation, which doesn't just draw a box but actually colors in the pixels of the object it sees. It includes not only facial feature detection but also face emotion recognition, alongside powerful yellow object detection and precise hand recognition. And with its self-learning classifier, you can train it to recognize custom objects in seconds, no PC required. It's professional-grade computer vision made plug and play. AI camera is packed with features, but one of the most useful ones is the object tracking. Check this out. To set it up, I just select the object I want right here on the screen, and it instantly starts tracking it. I can even label it directly on the interface. It's great. I can handle everything through the device screen without PC connection. And once it's locked on, it is fast. Look at how quickly it keeps up with the movement. The best part is that this is basically a complete finished device. We don't need to mess with conformer or write complex vision code from scratch. It already has all these functions built in. That's why controlling it over I2C or UART is so effective. It handles the vision, allowing us to stop worrying about algorithms and just focus on building our application. Now for the connections, the HuskyLens2 is flexible. It supports both I2C and UART. Since setting up UART on ESP32 is basically a walk in the park, that's the route I'm taking. In the box, they include this little breakout board. This helps us manage the external connections and the power supply without making a mess of wires. For the controller, I'm sticking with my old reliable, the ESP32-S3 DevkitC. It just works perfectly for initial tests like this. I have connected the usual suspects, RX, TX, ground, and VCC. One small detail to catch, this breakout board doesn't actually output 5V back to the ESP32, so I did have to run a separate 5V line to power the camera board directly. Okay, let's juice it up. I'll power to the HuskyLens and it's on. Now I will power on the ESP32 and watch this. As soon as it boots, you can see the camera reacting. That's the ESP32 sending our custom UART command to launch the specific AI function we wanted. It works. I designed this whole setup specifically for handheld use, something you can just grab and go. This of course runs on batteries. Since the battery pack is the heaviest part, I put this way down here to keep the center of the gravity low. It powers everything and makes the device feel really balanced in your hand. Up top on the left, we have got the HuskyLens2 camera scanning the world. And on the right, this beautiful 3.49-inch display running on the ESP32-S3. The ESP32 is acting as the host controller here. It's constantly asking the AI camera for updates, processing that raw data, and then turning it into something useful for us to see right on this screen.